Hi, I'm Professor David Farina. In today's video, we're going to be talking about the Sun, our star, in particular, the solar atmosphere. Let's get started. So, the Sun's atmosphere is an absorption spectrum. As we've talked about in previous videos, an absorption spectrum is simply when a cool gas is over top of a continuous spectrum. So, what does that matter? Well, it tells us what the Sun is made of, its overall composition. And when we look at the Sun, we find out that primarily the Sun is going to have hydrogen and helium as its two main components. However, it does include some other elements such as calcium, iron, and sodium. This indicates that our Sun is not a first-generation star, as it does include some metals that would only be formed in stars previous. In other words, our Sun had a grandfather and grandmother, a mama and a papa star that it was born of. This is interesting. It's actually a second generation or even a third generation star. Now, as we look at the solar atmosphere, it comes in many different components. The next layer up that we're going to discuss is the chromosphere. Now, the chromosphere is a layer of the Sun that is above the photosphere. It's very difficult to see because it requires you to view the Sun without looking at the photosphere. Now, there's two main ways to do this. One is during a solar eclipse, where you could view this with just the naked eye, with a total solar eclipse. The other way is through a hydrogen alpha telescope. So a specialized hydrogen alpha telescope will look at the chromosphere. You can see the chromosphere sticking out in this picture here in two locations. There's one, there's two. The surrounding outer region here is actually the corona, the next layer above. Within the chromosphere, we've got our solar activity in terms of storms, and these are mostly magnetic related things that you can see kind of sticking up here, prominences and spicules and all sorts of various different solar features. And finally is the corona. The corona is the outermost layer of the Sun's atmosphere, and it is only visible during a total solar eclipse. And the reason is because it's, although very big, it's not nearly as bright as the photosphere or the chromosphere. And in order to get a full picture of the solar corona, an eclipse is needed to cover up the Sun's photosphere. I've seen this personally. It is absolutely phenomenal to view. So next time we have a total solar eclipse, which if you're watching this prior to 2024, will be our next solar eclipse here in the Pennsylvania region. I highly recommend that you get out to see one. I believe it's in April. So please look into our other videos on solar eclipses to learn more. So in terms of a little diagram here to give you distances and temperatures, you'll notice that as we're closer and closer to the surface, if you will, remember the surface is the photosphere, the surface temperature, about 5,780, I believe it said, was the number here for the surface. Let's just call it 6,000 Kelvin. It initially in the chromosphere starts to drop off in temperature, and then it starts to rise back up. Finally, we reach the transition zone. You can see a very big jump in temperature until it finally reaches the corona, which is over 1,000,000 Kelvin. So this is kind of weird, and I'd like you to think about a bonfire. So if you were right up against the bonfire, of course the wood itself, the photosphere in this case, the wood would be extremely hot. It would be the hottest part of that bonfire, and as you step back slowly, you would find that you wouldn't reach a point when the temperature went up. It would always go down. So scientists were kind of baffled by this transition zone and the immense temperatures at the corona at over 1,000,000 degrees. How is this possible? Well, it's thought that there are magnetic activity that allow for this to occur. So in other words, the ionic charge, the charged particles, allow the movement of the Sun's hot gases to travel through magnetic fields to create a very high, denser region of the corona which reaches these millions of degrees. So thanks a lot for watching today's video on the Sun, our star, in particular the solar atmosphere. If you like this video, please click the like button. If you'd like to watch more of these videos, click subscribe. And if you'd like to get a notification each time I make a video, please click the bell at the bottom. Thanks for watching, and have a great rest of your day.